was all excited, and then I said, oh shit, it was a math teacher that bought me. Oh shit. Poor little phone. Alright, so 2 into 6 is 3. So I'm going to put a 3 there. 3 times 21, 63. Change the sign. 1. Does 21 go into 14? No. So then what do I put up here? 0. Then you bring down the 7. See, people forget that. You haven't done log division in a while, so I don't blame you too much. So 21 goes into 147. Did I do it again? Holy shit. Really, Jeff?
37.
That's hilarious. Alright, guys, just bear with me. I am going to go play the lottery. Doesn't this go in evenly? 21 into 147 is 7, and that's even, isn't it?
Yeah.
Alright, holy shit. Make that a 9 for me, is that alright? Or let me say it again. Make that a 9 for me. You guys kind of understand what's happening here? I made a random number and it just happened to go in evenly. That's insane. The chances of that are very low. So it's still 7, right? 7 times 21 is 147. So there's 2 left over. So how do I write this fraction at the end?
2 over 21.
307 is 2.
So you don't want decimal form?
Don't want decimal. No. You're going to see why. When I do this, you don't want to have like point x, 1x, x, 1x. No. No, you don't want variables in your decimal. You don't want that. So no. In fact, anybody who thinks they don't know this, yes you do. Because how do you write this as a mixed number? I know we did it earlier differently, but don't you do 4 into 9 is 2 with 1 left over? I mean, you already do it.
Yeah.
You already do it.
I've never seen it like that.
Okay, now you have.
Yeah.
Uh-oh, sorry. But that's what you do when you change it. Isn't that the way you change it into a mixed number?
So no R20, so no R2 then.
Oh, hell. That's Math 88. No, we're out of there. In fact, that's the beginning of Math 88. No. Okay, so let's do this. I didn't mean to make that sound like a question. So here's the problem as it will be given to you. Did I make this one? No, Jeff, that won't go anywhere. So you set it up the exact same way. Again, you guys are cool with the fact I cannot break this up. It's not going to get me anywhere. So I need a different way to do this. Alright. Now, the reason I made a point out of this, we did 2 into 6 and got 3, and then we brought the rest of it into play here. Do you guys understand what I mean when I say that? A little bit? Alright, so now watch. X times what is x squared?
X.
Isn't that like 2 times what is 6?
3.
So that's why we put a 3 there, isn't it? And then we multiply 3 by 21. Alright. So look at the first part. X times what is x squared? X. X times x? Yeah, that's what we just said. So that's x squared. X times 1?
X.
Is x. And again, what did we do here? When we put the 3, what's the very next thing we did? 3 times 21 is 63. Right? So x times this is that. Everything I'm doing so far is the exact same thing we did with the numbers. Exactly the same thing. Yes?
So now, when you subtract.
Good. So that's why I said it the weird way I did. You change the signs. I'm going to subtract this whole thing. So when I have variables, not numbers, I like to think of it as what it really is. It's changing the sign. I change the sign and then I combine. Because what did we do here? We did 3 times 21, 63. Change the sign, add. X times that is this. Change the sign, add. What's x squared minus x squared? Nothing. What's 4x minus x?
3x.
3x. And then I bring down the plus 5. X times what is 3x? 3. 3 times x? 3x. 3 times 1? 3. and then I
Subtract.
change the signs. 5 minus 3 is 2. So how do I write the remainder? Plus 2 over x plus 1.
If you repeat that last part,
So
right after you get 3x plus 5.
x goes into 3x, or x times what is 3x?
Oh,
3.
okay.
Just like x times what is x squared. Because what would I do here? What did I do with this?
Yeah.
2 times what is 14? 7. Right?
So you just do the first number on the left side?
Yeah.
You only do the first
Because what did you really do? Really think about what you did when you saw 21 goes into 149. Didn't you say 2 goes into 14.7? If you really analyze what your brain is doing, you ignore the second half of that number in a way, right?
Yeah.
So that's exactly, here I don't take that into account. I say x times what is 3x, 3, and then I multiply it by both. We really do the exact same thing. It's just that when we do variable stuff, we really have to analyze, oh, what did I actually do? Because when we do numbers, we don't even think about what's really happening. But variables are freaky. We got to think about, what am I really doing? Let's do another one. Yes, sir.
Can you repeat this one?
What happened?
Yeah, this one.
What about it?
What do you say? 2 times 1?
Yeah, when I looked at 21 into 149, you did not think how many 21s go into 149. I guarantee you didn't. You thought 2 goes into 14. You did. You just didn't even realize you were. But if you really catch your brain at that instant, you're like, oh, that is what I'm doing. Holy shit. Or you're, no, stop.
Like pick the first number?
Because that's what we do. And that's why it makes sense that that's what we do here. I can do x into 3x, but I can't do x plus 1 into 3. I can't. So that's why I do the exact same thing over there. I can't. So divide 6,487 by 39. Just do it. No, I'm not going to do that shit, Jeff. No, I'm going to think 3 into 6. I'm going to think that way. All right, let's do another. Bless you. Let's see. Oh, that's going to be neat. That's so neat. Okay, I'm getting really freaked out. I think this goes in evenly. Let's find out. And you're like, how the hell would you even know that shit? Well, it's not good. Alright. Let's do this one together, and then I'm going to unleash you on one on your own. What a weird day, man. If this does go in evenly, that's 3 of them.
So now you definitely have to play the water of lucky number 2.
No, it doesn't go in evenly. It's got a remainder of 14. Okay. Alright, we'll see. See if we come out with 14. Alright. So what's the first step here? We'll do it together, but you guys help me out. What do I look at? Yeah, x goes in it. X times what is x cubed?
X squared.
X squared. I like it. Somebody cool with that? No. So again, when I did this, whatever it was, I thought 2 times what is 6, right? And that's why I put a 3 down. And then we did 3 times 21 and put it there. So x times what is x cubed? What do I multiply x by to get x cubed? X squared. It needs 2 more x's. You have to be able to work with the exponents like that to be able to do this. That's really all you think. How many more x's do I need to make x become x cubed? 2 more. Man. So what's x squared times x? It's crazy enough. It's exactly what we just said. And then what's x squared times negative 3?
Negative 6.
Negative 3x squared.
Negative 3x squared. All right, we'll stop there. Second. Are you cool with the x squared? All right. X times what is x cubed? X squared. Okay. And then you say x squared times x is x cubed. X squared times negative 3 is negative 3x squared. I like it. Yes, sir.
So you divide each of
the x and the -3 into each term.
That's what we end up doing. But my point is, when I looked at this, I did not actually do 21 into 64. I actually thought 2 into 6. I didn't worry about the next part. That's exactly what we do here.
You just do the math as far as
X into x cubed is x squared. And then this comes into play. So here what's the next thing I do?
The same is true with every term.
Totally. Right? So what do I do now? Change the sign. Right, because I got to subtract that. So when I subtract something, the signs change. So what do I get here? It's always going to cancel. If they don't cancel, you did something wrong. And then here I get x squared. Alright, so now I'm looking at what? X times what is x squared? X. So x times x is x squared. Crazy. X times -3, -3x. Then I change the sign. Obviously, the most common mistake is not changing the sign. And that screws everything up. Those cancel. That is 7x minus 7. Now you see why I thought for a second it might go unevenly. But then I'm like, oh yeah, it's 3, not 1. Alright. So x times what is x? 7x, sorry.
Plus 7.
Yeah, x times 7 is 7x. So 7 times x is 7x. 7 times -3? -21. And then I change the signs. And there's your promised 14. Plus 14 out of x squared. That's the remainder term.
That last term won't be negative?
No, because -7 plus 21.
So, no, but I mean like ever, like
Oh.
the remainder part. When you
Of course
add it on,
it
it's
could.
always just added?
Totally could be.
Oh.
You could always say, like, if you came out -14, you could say plus -14, but that's kind of silly. You just go ahead and say minus. Yeah. So if this is negative, you would just say minus blah, blah, blah. I like it.
So is this just a different way to do the, instead of doing the x, like breaking it up? Or is
Yes.
it different ones?
It's not just a different way. It's the only way I can do this when the bottom has more than one term. If it was just an x down there, I wouldn't do this shit. I would just say that over that, that over that. But if I say x cubed over x minus 3, there still isn't shit I can do with that. I can't do anything with that.
So if it was 3x to the second power, then you would still break it up, because that's just one term, right?
If this bottom was a single term, any single term, then I would just break it up.
Without the division or subtraction.
With the division, right? So if the bottom was 3x squared, then I would break it up. If the bottom was 3x squared, y squared, z to the 4th, that is one term, I would still break it up. Why is this two terms? Because there's a minus sign. I like it. So what's the only time you have to do this long division weirdness? It's when the bottom has more than one term. When the bottom has a minus or a plus in it. Separating terms. I like it. Yes, sir.
If you start off on the negative x cubed plus 3x squared.
What's happening? Are you giving me a different problem?
No, I just got lost right there when you changed
Oh!
the first
Right
time.
here. Sure. X squared times x is x cubed.
Yeah, I'm at the end of that point. I just don't know where to go from there. I have the x squared.
Oh, here.
Yeah,
And then you brought down the 4x.
brought down to 4x.
Good. So then x times what is x squared? X times what is x squared?
X.
X. Because what did we do here? When we got to here, what did we do? 21 times what is 149? 7.
Yeah.
Right? And we're doing exactly the same steps. I know your brain is saying, no, I'm not. And I'm like, yeah, you are. You are. Oh, let's see. I want to do one more. You want to do one more of this?
Sure.
Sure. Okay. Let's do one. Let me see if you guys catch on to this. do I want to? Yeah, sure. Let's go crazy. Yeah, man. So there are two things that are different here. The most obvious one is the bottom now is squared, right?
Yeah.
But it still works the same way. The other not so obvious thing is the top is missing a term. So how many x squares does the top have? Where is it? Where is it? How many x squares does the top have? 0. Yay, Jeff, again. You're amazing. So watch what I do. I'm going to write x squared plus 1 into x cubed plus no x squares plus x minus 1.
Huh?
You like that? So, because what's... Is that different from what's there? Let me show you why I do that.
It's the placeholder.
It's a placeholder, just in case. Now, in this case, it's a placeholder in case you get...
Zero over there.
Totally. Sort of, yes, but that wasn't the answer.
Oh, I know,
this one is like, this is so subversive. If I write 1014, what do numbers have that variables don't automatically have? A way to represent that there's none of something. So I have to represent that there's none. It's like not writing that. Then what are people going to think? Is that a 1 and a 14 or is that 114? No, it's 1014, man. It's a blank. No, it's a 0 there, right? That's why we invented 0. Yes, 0 had to be invented. So that I gotta show that there's no x squares. Just in case I get an x squared, where the hell would I put it if I didn't have that there? So it's like a like terms placeholder. I like that somebody said that. Now in this problem, I don't think we're going to end up with one, but just in case we do, we have to have a place to put it. So again, it still works the same way. X squared times what is x cubed? X. X times x squared. X cubed. X times 1. X. Now, we didn't get any of these, but we put it there just in case. Because why didn't we? Because this is missing an x term, right? Do you guys see that? But you got to put it there always just in case. So then what do I do now? Change the signs. Good. Those cancel. No x squares. Those cancel too. That's neat. I like that. So then you bring down the -1. Now, can x squared go into -1? No. So you know you're doing. So minus 1 over x squared plus 1. Such a weird day, man. I did not design it so those would cancel. It just happened. What's up?
So, again, you just completely threw a curveball. What's that? 0 x squared.
Yeah.
All right, all right.
So you don't do anything with it at all?
All right, watch this, real quick, real quick. All right. The mistake I made there was I put too much new stuff in one thing. Go with me. Ready? Let's not put the placeholder there. In fact, just watch this. Don't even write it. This is wrong. So if I try to start doing this, x times what is x squared? X. X times x is x squared. X times -1 is -x. It doesn't have a place, right? So I want to put no x's plus 4. So when I get x times -1, there, it's got a place. Holy shit. That's all. That's all. Here, I did 2 changes at once, so it ended up with no x squared. So it's like, why do I need it? In case you do. That's why you do it, in case you need it. So now this you can write, this you can write, because that's right. I put the placeholder, there's no x's in the top. So I just say, there's no x's on the top. So, change the signs. These cancel. No x's equals 1x is 1x. Bring down the plus 4. X times what is x? 1. That's crazy. So I get x minus 1, change the signs, 5, so it'll be plus 5 over x minus 1. No, x times 1 is x. So x times what is x? 1. So what are you putting on the top always? What this guy needs to become whatever this is down here. Always. Yes.
So then the last problem, since there was nothing that was x cubed, you just put it, you just moved it.
There was nothing that was x squared, so I didn't need that in this case. But why did I write it? Because I didn't know ahead of time that I wasn't going to need it. So I always write it just in case I need it.
And you can't.
What's up?
I was gonna say, but I don't think so because you can't put. Because I did it wrong the first time, and I put an x under the 0x. I put an x. I put x under 0x squared, but then it didn't make sense because there's no x squared.
I got you. Yeah. So you got to be careful there. You always line up your like terms, but it's there in case you have like terms with it. If it wasn't there, then it's like you would put it on the side, but then it gets weird. You might forget it. I don't know if that makes. Just do it. Trust me. It'll make it easier. All right. Let me see. Last thing for today. And to be honest, I really only gave you a couple of these kind of problems in the homework because it's not a huge focus. I know I spent a lot of time because it's a different idea. But in the next level of math, it's going to be a little bit more important to know how to do that. And especially if you're going beyond that, you're going to want to know how to do this. So just a little bit of a preview. We already had a slight preview of Chapter 6 yesterday when we did the bonus question. All right? If you weren't here, oh well. The Chapter 6 is all about doing Chapter 5 in reverse. Because what is math always able to do? Go both ways. Total, right? If I can add 2 to something, I have to be able to subtract 2 from it to bring it back to where it was. Does that make sense? There's always an opposite procedure. Don't think poorly of it. Right? Don't make judgments about math. Oh yeah, so the very first type of factoring, I like to introduce it before I even call it factoring because it's just distribution in reverse. So let's recall, how do I distribute?
12y
Yeah,
squared.
so multiply 12y squared. So all Chapter 6 is going to do is they're going to give you this and say, where did it come from? Or at least Section 6.1, let me say it like that. Because we're going to obviously get more advanced factoring problems. So then you'd say, what do these both have? Both the numbers have 6 in it, and they both have 1y. This guy's got 2, so it definitely has 1. So you're always taking out what everybody has in common. The biggest thing that all of them have in common, and that's why we call this greatest common factor. It's the greatest American hero. No, common factor. GCF. All right, so let's try a couple of these out. Because this is not the way it's going to be given to you. It's going to start here. So if I gave you this problem here, so you attack it piece by piece. You look at the numbers first, and then you look at the letters as they come. So what number can come out of both of those numbers?
5.
Let's start this. 5 comes out. Now watch what I do. I put it a little bit over there, and I'll show you why. People make this simple mistake. 5 comes out of both of those. How many A's come out of both?
1.
He's only got 1. So notice, a shortcut for the variables is you always take out the smallest power you see. Because that's the one that everybody's got. He's got 3 of them. Well, that's nice. He's only got 1, so I can only take 1 out of both. There's something going to be left there, but okay, great. So I take 1A. How many B's?
1B.
1B. Now you maybe see why I put it over here, because now the answer for this goes right underneath it. I'm not going to forget it. When people write this here, they put the answer and they forget about this poor dude. It's a little thing, but it's really annoying for you and me. So just push that over there. Now, the answer for this is going to, what? 5 divided by 5 is
A squared.
1.
Squared minus 2.
Yeah, A cubed divided by A, there's A squared. There's 2 A's left, and I took that B away. Minus 10 divided by 5 is 2. I took his AB away. Aw. And just like reducing a fraction, you might not have taken enough out in the first place. So how do you know you're done? When they have nothing in common at the end. All right, cool. So let's do a little bit more interesting one. So hopefully you understand. I don't care how many terms I do. It's the exact same idea. Now I just have to look at all 3 terms, though. What number comes out of all 3 of these? 2. I love it. 4 comes out of these 2, but then that guy, oh, screw you. So I can just take a 2 out. And what about the x's?
1x.
1x, good. You always look for the lowest power. You're like the fair tax man. You only got 1, I'll just take 1 from you. Right? At least they don't take more than I got. Which didn't always used to be the case. So then an x comes out.
Y squared.
Good. Y squared. This guy got 3, but they can only give 2. Z4, I like it. Because that's the smallest number of z's, so they can all give 4 z's. You don't take more than anybody can give.
Can you repeat that?
2. Because I had 3, I took 1, I got 2 left. You see that little discussion I had with myself? I had 2 y's, I took 2 y's. I had 7 z's, I took 4. Z cubed. I like it. 12 divided by 2. I had 2 x's, I took 1. I want to hear more voices. I had 3 y's, I took 2. 1 y left. I had 6 z's, I took 4. 2 z's left. What's up? You know what happened? Did he end up with more than he had to begin with?
I said 7 for some reason.
Oh, because my z's look like a 7 thing. Now, this last term is what people freak out about. Some people do this. That's bad. I can't have 3 terms and then 2. Yeah, this divided by itself is 1. Another way to think of it is, if that wasn't there, how do I check this, by the way? How do I check division? I multiply. So if that wasn't there, where would that come from? Bullshit. So it's like a placeholder. But better is something divided by itself is freaking 1. That just makes total sense. It's got to be 1 there. Alright, so that's the first form of factoring. There are many forms of factoring. That's why chapter 6 is so long. I do have a handout I'm going to give. Once we talked about all the forms, I've got a handout that summarizes all the forms and tells you how to identify when you're looking at a certain form. But that's enough for today. Just can't talk anymore without water.